This is a tutorial video that explains, using step-by-step instructions, how to create relational database tables on the Didgets platform. If you have not seen the introductory video, I would recommend seeing it first. I won't try to show all the powerful things you can do with these tables during this video. There are other videos that show those things. Here I will just focus on various ways to create one or more of those tables. So here we have the files that we downloaded from the download site. Here's our Didget browser tool. So if you just double click on that, it'll bring up the tool, which will show you the pods here on the left. Click on the pod you want to look at and the databases tab for that pod. Here we have a default database, which is just a list of digits that are part of that database. Within this database, we have a couple of definitions. We have a friends and a customers definition. These are basically just schema that define the columns in the tables we want to create. The friends definition has 6 columns, all strings. The customers one has 10 columns, which most are string, but the zip code is a number. We also have a set of connectors. We've got Postgres, MySQL, SQL Server connectors to external databases, so we can pull data directly out of those into our tables. And I've created here 4 different tables previously with various numbers of rows and columns in them. Let's show you how to, let's create a new demo database here that will be empty. So we'll just come here and you see there's no definitions, no connectors or tables in this one. So let's say we want to create a new definition. We can do one by scratch. So we want to create this. Let's say we want to create a new contacts definition, and we're going to create a name which is type string. If we wanted every name to be unique, we could make this a primary key if we wanted to, but we won't here. We will add another one for their phone number and another one for their email. And we say okay. Now we have a new contacts definition here with those 3 columns in it: name, phone, email. Now we can just create a table based off that definition right here. We'll call it a contacts as well. And now we have an empty table that has no rows in it, but has those 3 columns. Let's say we want to go add some data to there, so we can insert some table rows directly on that. It gives us a nice little form with each of the columns, and we want to have Bob in here. His phone number is 123, and his email is bob@here.com. And we add that in. So now we've got 1 row in there. We can clear those out, and now we'll do Bill. His phone number is 345, and his email is at bill@b.com. So now we should have 2 rows. If we're done here, you'll see now we have 2 rows in the table. We have Bill and we have Bob, and there's their phone numbers and emails. So that's a way to build a definition from scratch and manually enter all the rows if you want it. It's not very friendly for if you have thousands and thousands of rows. So let's go and show you an easy way to import files using this definition. So here I've got a little friends with 100,000 rows in it. It's a CSV. You'll see it has a header, the name, address, city, state, phone, email. But I have no definition to drop this thing on. So I'm going to just grab it and drop it into an open space within the definition window. What that will do is it will create a new definition. We'll just call this, take off the 100K and make this friends. And we say okay. So now that created my definition based off of that first row in the table. And now it gives us the opportunity to import the data. And we want to just import all the data in there. You'll see it pull in the 100,000 rows. And so now I have a table with 100,000 rows of names, addresses, city, states, phones, and emails. It's a really nice way to to grab the data. But we have this definition now with the name, address, city, state, etc. So I could take another file. Let's see, I've got one here that has, names and addresses and things like that. Let's grab this one. But the things are in different orders. The email is first, then the phone. But I have the header line here that matches this definition. So if I just grab that, drop it on my friends, and we'll keep it as the file name as the table name. So now I have a friends 2 with also 100,000 rows in it. But it put them, again, put the email in the right email column, even though the data within that file was in separate orders. It follows that definition now and puts everything in the right columns. I can import JSON files. So you see I have a friends.json here, also with 100,000 rows. So if I drop that on the open area, it will grab, let's see, friends, we'll call this friends 3. Again, it grabbed the definition. If we want to see what it did, it grabbed it right out of the JSON file. Lets you edit it if you want, and import that in, and now I should get a friends 3, also with 100,000 rows based off that JSON file. So we support a number of formats, and you can just import the data, create your tables right here from a definition. If we want to grab data directly out of another external database, let's go back to our default where we had connectors to Postgres. So within Postgres, I have a view that I previously created here, but let's say we wanted to grab some different data here. Let's create a view, and I've got a number of tables or views in this. I only have tables in this. Friends, crimes, customers. We'll just grab that same friends. So you click on the table you want to import the data from your Postgres database. You set up the view. We want to have people in states that start with the letter M. So we create a filter by clicking on the Create Filter button. We want states. So we grab the state column, and it starts with the letter M. Show the SQL right here if we want. It's going to select star from that friends table where the state begins with the letter M. So we say OK. Now we have a view here. And if we want to create a table from it, we just double click that view. It'll create a new table, people in M states. We'll keep the same name. We could change it here if we wanted to, but we'll just keep it. You'll see it's fetching those 78,307 names out of that friends database inside of Postgres. It created a digit table that has 78,713 rows, and all the states should start with the letter M. If we just show all those values here, we'll see there's 3, 6, 7, 8 different states from Maine and Michigan and Montana and Minnesota, all the states that have an M starting with them. So that's a way to pull data in and create database tables by looking at just the connectors to a database, to build it from scratch, or drag and drop files directly onto a definition, or create a definition by dropping it into an open area. There's one further way in which we could create a table inside of Didgets from data, and that is, let's say we've got our M states here with 78,000, and we want to look at just the ones in San Bernardino. So we get this nice little result set of 84 people that are in San Bernardino inside of an M state. If we click here and we say select everything, and we want to save that to a table. Let's see. And we want to call this table just ABC. We'll just give it a name here. it grabbed all those values, created a new table with just those 84 rows in it. Sure enough, if we look over here, we'll see our ABC. It has 84 rows in it, and it's a standalone table that only has the San Bernardino in M state rows in it. So that's a quick way to build some various tables, and then we can start having some real fun in querying these tables, exporting them out, doing analytics and cleaning up our data. And we'll show those in further videos. But just this introductory to show you how to create these tables in various ways. Thank you very much.